on.
So, hello everybody, and welcome to our last day of the conference here in Florence. After a lot of days with web-based technologies and three-dimensional things, here it is, an old school talk by Peter. Thank you.
So hello, I'm Peter. I work at Red Hat on identity management, bringing a little Python to enterprises. In case you haven't noticed, Red Hat is hiring, so if you're interested, go there. I also help organize Python meetups in Brno, so if you ever visit the Czech Republic, go to python.cz. But what we'll talk about today is consoles. So in the old days, when computers got fast enough to be interactive, people connected them to teletypes, which are basically a typewriter and a printer. And you can send messages to another teletype, or you can control a computer with them. That's still in the TTY contraction that you can see sometimes today. It's called also a terminal because it was at the end of the wire, or a console because it pretty much was a big box. Then a bit later came Unix and said everything's a file. So normal files are files, disks or partitions are files. Anything you can read from or write to is a file. So a network socket, a pipe. So terminals also are files in Unix. And the way it works is you write something on the keyboard, goes through the kernel, and the process gets it on a special file called standard.in. Process writes something out, it goes through standard output and to the screen or printer or whatever you have there. You also have standard errors, so you can redirect those independently, and something that processes the standard output wouldn't get confused by all your error messages. It's a bit complicated now because this whole machinery for interacting with the hardware terminals is connected to a pseudo terminal and a terminal emulator, which draws stuff in your nice little window on your graphical screen. And it's also a bit more complicated in that if you type something on the keyboard, it doesn't go directly to your process. Because what happens if you, for example, press backspace? We don't want the process to handle backspace, so the kernel keeps a little buffer, and you can edit that buffer, and whenever you press enter, the whole line gets sent to the process. You can control this functionality by a syscall called IO control, which is pretty much do something to a file that's not file-like. So you can turn off this functionality or modify it in different ways. Another thing the kernel handles is if you press Control-C, it sends a signal to the process saying, hey, somebody wants you dead. And if the process doesn't respond, well, so on. You can also press Control-Z, which suspends the process, and there's a whole machinery involving signals and sessions that makes this all work okay. There's also window size. Each terminal has 2 numbers attached, which is pretty much the resolution of the screen. So this screen is 41 by 17 for some reason characters, and the process can get that information, and whenever the screen size changes, a signal gets sent saying, hey, you should read those 2 numbers again. You can look at all these properties a terminal has. There's quite a lot of them. There's a speed for all terminals, there are the rows and columns, there are settings for what keys control this signal functionality, a whole slew of stuff I have no idea about. This terminal was in UTF-8 mode, and echo means that when I type something on the keyboard, it automatically appears on the screen without the process doing something. And you can of course change all of these, turn them off and on, and so on. So we have these are the kernel handles, what the kernel handles. And the terminal itself, because many companies made them and they wanted to be better than everybody else, so they added some new functionality like bold text. So you send a special character saying, I want text to be bold now, and all the text that you wrote from that point on was bold. And then you send a character that said reset. You can get colors this way. You can get underlined text. You can get blinking text. You can also move the cursor. So if you want to write something in the middle of the screen, you send special character that say, these are the coordinates I want the text to be displayed at. And it would. There's an ASCII code for beep. You can change character sets, so you send special codes and then the rest of the text is illegible. Fortunately, you can also use Unicode these days. If you ask nicely, you can also get the mouse input from terminal emulators. And so there are all these different things, and not all terminals support these, and some support a bit more. So it's pretty much all a giant backwards compatible mess. So why do I use this? Why do I use this? You use this because text user interfaces are simple. We all started writing a text user interface. You know? Text user interfaces are universal. Try going to the manual of your favorite library and it'll say, to use this, do pip install by shinylib. There's this assumption that terminals are on every computer. If a computer doesn't have a terminal, it's probably a phone or some other entertainment device, whatever. Text user interfaces are scriptable. You can take the output of one program and pipe it to another program, and that other program can parse the output successfully or not and do something with it. Of course, you can use JSON for this, or you can use REST API, but in that case you have to have a server, and it's all very complicated. Also, simple text formats work in every language. If you use JSON, it doesn't really map well to, say, C. If you were at the Google Code Jam, you could notice that the inputs and outputs to all the problems were simple, space-separated text files. Also, text user interfaces are lightweight. If I streamed this presentation via Telnet or something, I would transfer about a megabyte, which is nothing, and it's not very optimized. And also, text interfaces are cool, right? At least to you. Otherwise, why are you here? Now, we're a bunch of geeks who want nothing else than to stare at green text in a black background, right? So what are the types of text user interfaces? We have line-based, like cat, grep, git, simple stuff. We have full screen, like these slides that take over your terminal. So the first one is simple, universal, scriptable, lightweight. The second one, not so much. So when you build a text user interface, you should decide which one you want to do. You want to do a line-based and make it friendly with all the other Unixy stuff on the system, or you want to make it cool and full screen, and in that case you should probably go for a traditional desktop app or a web app or something. If you're doing something for users, if you have a UX designer, then you're probably not doing a text app. A text app is for guys like you. And once you have that, you parse the command line arguments, which pretty much have to do for every app. You handle the input somehow, and you output the output. So the first thing is the command line arguments. Normally, you use what's called the GNU style. There are other styles too, but this one is used pretty much everywhere now because it's better. So you can have positional arguments. You call the program with some argument like the file you want to process. Then you have options. Single minus means a single letter option. Two minuses means a full word option. And options, of course, can have arguments too. And you can have more options. And then there's this pretty relatively new thing called subcommands, which means you have one command that does that has different subcommands like git log, And then you can have options that apply to the git command, like configuration, and you can have options that apply to the subcommand, like that. So how do you do this in Python? You import argparse. There's also an older one called optparse, but yeah, you should use the new one. So how do you use argparse? You construct an argument parser object, you add argument objects to it. These are the names. There's an action that it should store some value. There's some help text. You can add positional arguments pretty much the same way. And then you parse the arguments and you get them in a nice little object, and you can access them by attributes. Now if you leave this thing out, it uses the arguments you get from the system. That's the program's called with sys.argv. Now how do you document these? You can have a help option which pretty much writes out a cheat sheet of what each option does. You can have a man page which is a little more verbose but not too much, and it should document everything your program does. And then you of course can have traditional websites, tutorials that get users engaged and look pretty and stuff like that. So argparse will make this help for you, or at least the first one. So if you call it with the help option, the whole help gets generated automatically. So you only have to deal with the other two. There's also DOCOPT, which is pretty nice. Use it like this. You write the help text yourself, and then DOCOPT parses this help text and generates the option configuration for you, and then you can parse the command line arguments and you get them in a dictionary like that. So if your arguments are static, if you don't dynamically generate, this object has those kind of arguments and stuff like that, you should pretty much be using DOCOPT. Also, if you leave this out, the system or the sys.argv is used. The top level structure of a program should look like this. You should have a main function that gets the arguments and returns some value, and then you should call this main function. This is like a C-style main function, and what it does, instead of relying on the automatic functionality of sys.argv inside your main, is makes your main debuggable, or testable, sorry. So you can call it in a test and give it different arguments. Now if you want to do some fancy output, you can install a package called term color, which does colorization. So you import the colored function, you call it on some text and say, I want this text to be red. And voila, you print it out and the text is red. How this happens is how I told you earlier. Some special weird characters are added that mean this text should have color 31, and 31 is the code for red color. Then there's the text, and then you have something that says the color should be 0, and 0 is reset back to normal. So these codes work on Unix, they don't work on Windows. On Windows you have to use system calls or WinAPI calls. But you can also import Colorama and do this at the beginning of your program, and then every special character or the ANSI control code you write to standard output will be hijacked and removed from that stream, and the corresponding Windows API call will be called. Of course, on Unix systems it doesn't do anything, so you can use it easily. You can also use a package called blessings, which does pretty much the same thing, but a little bit differently. You import a terminal object, construct that, and then call a method called read. And the way it's done this, the reason it's done this way is because Blessings is pipe friendly. So if you redirect this output to a file, and so it doesn't go to the terminal, it turns off the coloring, so that the command that processes the output of your program will not get confused by all these weird characters or the escape sequences. Now if you do this, it's very good. If you do this, you should also have a command line option to turn the coloring off or on. So if you pipe it to something like less -r, which actually understands the colors, then you do get them. So if you ever color text, this is the law, obey it. There's a package called Clint on GitHub. It does everything you need for command line or line-based interfaces. So it has coloring, it has indented printing, it has columns, it has progress bars, it has some argument handlings, it has some interactive prompting, it has join with that puts and in the proper place and stuff like that. And if you submit a pull request, it'll probably get in. It doesn't have other things. Yeah, with all respect to the author, and I do mean that, I'm pretty careful about libraries like this, so I recommend either helping out or just looking at the source and seeing how these things can be done and then doing it your way. There are two very Unix specific libraries in the standard library. One is termiles, which lets you call the IO control syscall, which I talked about earlier, so set all the different properties of the terminal. And then there's TTY, which is a higher level wrapper around that. So you can set cbreak. What that does is when you press a key on the keyboard, your program gets it right away. The problem with TTI is that there's not much way to revert this change. So what you end up doing is getting the state, then calling set cbreak, and then by some magic you find on Stack Overflow or somewhere you turn it back. So not too useful there. Okay, that was pretty much the line-based. And now, if you want to do the full screen applications, you can import cursors, which is like a full screen text user interface library. You write data to a buffer, there are some helpers for that, and then let cursors display it. And it has virtual windows, so you can have portions of the screen that are pretty much independent. There are different implementations of cursors, and yeah, cursors, the name stands for what you'll do when you try to use it, pretty much. Yeah, it's a very old C library. There are various implementations, so you can never be sure which one you're using. The Python wrapper is very thin, so if you use characters, for example, you have to use the integer numbers for them. There are not much doc strings. It's pretty bad. But if you know how terminals work, and if you've used it before in C, then it's perfect. For the rest of us, there's Urwid, which is a widget-based library, like what you'd find in, say, Qt or Kiwi or something like that. It can use cursors under the hood. It can also just do away with all that and use raw control codes. You can also take HTML screenshots of your applications. Very nice. Widgets work something like this. You can have scrollable lists. You can have progress bars. There's quite a lot of them already ready, and if you've used Qt or GTK, it works pretty much the same as those do. So you have a pile which puts two widgets on top of each other. Text here, text there. Then you wrap it all in a line box, and it also handles input, of course. So one widget has focus, and keystrokes go into it. Also handles mouse input by default. So you get mouse events just like keyboard events. The problem with that is if you tell the terminal that you want to get mouse events, then the terminal emulator doesn't get to use them. So here I can select some text and copy it to my system clipboard. But if my program handled mouse input, I wouldn't be able to do that. So I recommend always turning this off, because it's much easier to use something that you can get data out by copying. If you don't do it, you have to provide some other way to get the data out. And that's it. Thank you. I thought this would take longer.
Okay, any question?
Hello, thanks for the talk. The last bit you mentioned, I mean, you could also implement with Widget selection and copy-paste yourself. I mean, or the library could actually implement that, right?
The problem is that the terminal is sort of not integrated with your graphical system. So you would have to decide if there's a graphical system running and do some kind of interaction with that. So it's not that easy. And the mouse input in a text user interface is not that important usually.
So I have a question about, you said that this one of this lib just discovers that the program is piped and automatically turn out the colors. So how do you can do by yourself in your own program? How do you discover that your program is piped actually?
Okay. What's it? ATTY, yeah. Thanks.
Does Widget support proportional fonts in any way?
No.
Okay.
If you want proportional fonts, then you should build a web view app. Or, well, okay, some characters are bigger than others, even here. So if you have like Japanese characters, they take pretty much 2 blocks. And Widget supports that, but it's not really proportional font.
Hi, thanks for the talk. Do you know something that helps to generate autocompletion for the modern shell, like Bash or...
Generate autocompletion, okay. There, I think readline would do it. There's a library called readline that you can import, and yeah, look in the documentation, I'm pretty sure it does that.
Anybody else?
Actually, for autocompletion in Bash and other shells, there's a thing called argcomplete that'll take your arg parse and generate all the completions automatically, so you can use that to sort of automatically generate all the completions.
You meant this for Bash?
For command line, yeah.
Well, readline is for when you have a Python program and you're implementing a shell in that. So you can have completion there.
Anybody else? Questions? Okay.
Can you tell something about compatibility between different systems, for example, Windows, Mac, and Linux?
Okay, all the full screen apps I showed here are pretty much Unix only. It probably wouldn't take that much effort to port Urwid to Windows, but nobody seems to be interested. For the blessings, you can use the Colorama with it to wrap it, and it'll work. So the line-based ones, there's no problem there.
In the abstract, you also mentioned the Midnight Commander. You may want to spend a couple of words about this wonderful application, which almost no one apparently uses. Thanks.
Okay, I won't try to. So, Midnight Commander is pretty much a file browser for the command line. So, you can browse files, you can view them. Let's see. The slides are a YAML file that looks like this. And yeah, but it's pretty awesome. It has all the functionality geeks put into it. So the documentation is, of course, also pretty huge.
Yeah, hi. Did you give your presentation in some terminal tool that you made yourself, or
yes,
what
it's
is
made
that?
in Urwid.
Sorry?
It's made in Urwid, yes.
All right. Can we find it somewhere, or can you tell us
yeah,
something more about it?
Yeah, I'll put it on GitHub just as I get some internet and free time. But yeah, it's a one-time use tool, and it's not too polished, so the code is not that great. I had to. I made a little. See. I have this confidence monitor, and Urwid doesn't really support having two screens, so I had to monkey patch it a bit, and I'll probably send a pull request to make it official. But
anybody else? Actually, I have got one question. As you said, sometimes there are programs that detect whether you are on a TTY or not. Is there any way to spoof those programs and make them think there is a TTY? For example, when you run a super user, you need a TTY, otherwise it usually refuses to accept a password.
Yes, there is a command line tool to do that. I don't remember the name.
Okay, maybe I'll catch you up with you later. So.
Yeah, there's a command line tool that does that.
Okay.
So you run that and then your program, and it wraps that in a sudo TTY. Just Google it. Or you can use screen, yes.
Oh, I had never thought about that. Okay, thank you.
Or Tmux, of course.
Maybe do you know any library that would help to build a tool like a varnish hist? So it's like a histogram plotted on. So actually plotting any kind of.
Actually, Urwid has some plots built in.
Okay.
Maybe there'll not be enough for you, but it's pretty easy to make your own. It's just putting text on the screen.
Okay. Anybody else? Thank you very much.